Yeah, where with the A and the R and the 40 degrees.
Uh-huh.
There's another line going from next to the 40 degrees to the disco ball.
Like this?
No, more from the disco ball to right in between the A and the R.
Like this?
No, like on your first picture.
Okay. You're gonna have to send over. I've still
Yeah,
got nothing.
totally.
Let me just type the email address. You can either reply to the booking email, which is what I recommend, or just send directly to here. I could also give you, here's a phone number you can text. That's the business. You can text if it's
Okay.
faster. We gotta get something over here because talking math isn't usually very effective. So
520. Let me know if you
sometimes the
got that.
school accounts you can't send out outside the domain.
Yeah, no, I mean I took the picture with my phone, but I just sent a text to that message
Okay. I've not received anything
to that
quite yet.
number, and then I replied to the email too.
Okay. Okay. If you want to provide your number there in the chat, I'll text you from this number and hopefully we can get synced up here. Yep, there it is. So of course it
Oh,
comes
nice.
in right now. Nothing, there it is. All right. So the image did come in.
Okay.
That really took a long time. Yes, so here we go. Let me snip that in and we'll get started. Okay. Yeah, I see I see why we were off on our drawings.
Mhm.
Or I was off on my drawing. Okay. So Annabelle and Rich, the same decorations, like you said, the disco ball's up here. There's a distance X and there's a 5 between them, and there's 2 different angles. Is that clear?
Mhm.
Okay, so there's really 2 triangles here. There's the one that's got the X and the 50 degrees. Okay.
Yeah.
And then there's another one. There's another one here that's X and 40 degrees. Do you agree with that?
Mhm.
Okay. Now we're gonna label this distance right here Y for the moment,
Okay.
which is right here. That's Y.
Mhm.
Is that okay? Is that clear?
Yep.
Now in the larger one, the length of the base is 5 plus Y. Do you see how I've done that?
Oh yeah.
Okay. This is key. Like this problem requires you to draw 2 triangles and then do something else. But is this part feel good about?
Yeah, that makes sense.
Okay. Now, if we look at just the small triangle, okay, the tangent of 50 degrees is what divided by what? What is tangent in terms of your trig functions? Do you remember from class?
Opposite over adjacent.
Right. So in terms relative to this 50 degrees, what's opposite? Is it X or is it Y?
X.
It's X. Okay. And adjacent is Y. And then we can do the same thing on the right here. Tangent of 40 degrees is opposite X over 5 plus Y.
Okay. So.
So I'll let you get caught up here.
Okay.
Now, this is super important. In principle here, you've got 2 equations with 2 unknowns. Okay.
Mhm.
And that's good. Like that's enough to be able to solve this. You just may not know how to solve it. But you have 2 equations and 2 unknowns. And that's what you were referencing earlier with the substitution.
Mhm.
Have you seen this before, or is this totally foreign to you?
No, yeah, I've seen this.
Okay, so on the left here, I'm gonna choose to solve for x.
Hmm.
Okay, and to do that, you're gonna multiply both sides by y,
Yeah.
which clears out the y's. Okay, so that's x equals y tangent 50.
Hmm.
Is that okay?
Yeah.
Now in the other equation, wherever you see an x, you're gonna replace it with y tangent 50. That's the whole point of why we did this.
Oh, okay.
Okay, so we're down to one equation and one equation with one variable, y tangent 50 over 5 plus y. Okay. Now this doesn't look great, but it is enough to be able to solve this. Like we have one equation and one unknown. Now
Okay.
let me know when you get caught up to this step.
Okay.
Okay, so I'm just going to rewrite it here. Again, sometimes it's unclear what to do. The tangent of 40 and the tangent of 50, they're just numbers, okay? Now, what some students like to do at this point is they like to put it in their calculator and get the numerical value. I'm okay with
Mhm.
that. I actually prefer to wait till the end, but if you're like, hey, I really want a number, the tangent of 40 is 0.8391.
No, that's okay. I'm
You're
good
okay.
with
Okay. Okay. Oh, good. Okay. So we're gonna multiply both sides by 5 plus y, or basically
Mhm.
cross multiply. So it's 5 plus y in parentheses tangent 40 equals y tangent 40, 50. And then
Oh.
you're gonna distribute this tangent 40 to both. So it's not just the y, it's 5 plus y in parentheses. So it's 5 tangent 40 plus y tangent 40 equals y tangent 50.
Uh-huh.
And you really want the y's to be on the same side. So you're going to move this y tangent 40, y tangent 40. So it's 5 tangent 40 on the left equals y tangent 50 minus y tangent 40 on the right. And you can factor out a y. They both have y in it. So it's tangent 50 minus tangent 40.
Sorry, just give me a second.
Sure. Yeah, take your time to get caught up here.
Oh, and you got from distributing, so y10 for you.
You're factor out
Yeah.
y.
Can you scroll up a little bit? Is
Sure.
that okay? Oh, okay. Y10. And then we subtracted y1040 from both sides. Okay, cool.
Okay, so let me know when you get caught up to this step because we're basically done. You just have to divide and then put it in the calculator.
Okay.
Okay, so we divide both sides by this tangent 50 minus tangent 40. And that is your final answer. You just got to go to your calculator and put that in correctly. The bottom needs to be in parentheses.
5, 10, 40 divided by.
Let me know what you come up with.
Mm-hmm. I got negative 18.38.
So we know that can't be right because for a couple of reasons, distance can't be negative. Okay.
Oh, I don't think
Is
I put the minus.
it possible that you? I mean, we want to recalculate this, but like make sure your mode is in degrees. And if you need help entering this calculator, I've got a TID3
Oh,
virtual.
I'm not in degrees.
Yes.
Oh, it's because I reset my calculator. Okay. Okay, let me try that again. So 40 divided by 50. 40. Okay, so I got 11.896.
So we'll go 11.9
Mm-hmm.
right in there. And then that's in feet, by the way. Unfortunately, this is not the answer. Like you did all this work, right? And you're like, what do you mean it's not
Mm-hmm.
the answer? Well, if you go back to our drawing, y is the horizontal distance. And what do they want?
X.
They want x. So you're almost there, but you got to do one more step. X is y times the tangent of 50. So you have to reuse this equation to find x. And you're going to do that by taking that number you just found and multiplying by the tangent of 50. Let me know what you come up with.
I'm sorry. So
Do you see this
my y
equation?
my y is gonna be y tan
No, no,
or no.
your y you just found. You found y is 11.9.
Okay, yeah.
Okay, but you that's
So
not the
then I
answer.
just plug that in and
Yes, you got to plug it in for y to get x. It's like a substitution system where you go back and find the other variable.
ten 50. What was 11 over?
Do you have a final answer for me on that one?
Yeah, I'm about to get it.
Okay.
X is 9 point. X is 10.
So I mean, we're not, this is, you don't make this overly complicated. It's your x is y times the tangent of 50. And so it's 11.9 times the tangent of 50.
Oh. Oh.
There's nothing more to do. Like it's not a more complicated formula. I think maybe you divide it instead of
I
multiply.
did. Yeah, I
Yeah.
divided. So 14.2.
Yes. Feet.
Okay. And why did we multiply instead of?
Because it's y. You have y. You're given the value of y, so y is in front of the tangent. So that when they're squeezed together like that, you multiply them. Like the analogous problem is, let's say you found that y is 3 and
Mhm.
x is y times 4. Well, you're going to put that number in for y, 3 times 4.
Oh, okay. Okay. Can I look at the work you did above that?
Sure. None of this is related those to x. It's just for y.
Yeah, sorry. I meant the I want like your drawing of the triangle.
Okay. Right here.
Yeah.
Okay.
And then so yeah, I for the first triangle that you drew, the one with the 50 degrees, I plugged in my 11.9 there. Yeah, right at that Y.
Okay. That's fine. But I mean, you've already solved for x. Like we already did that as part of
Oh.
this. Like I think you're adding additional
Yeah,
work.
yeah. I see what I
And
did now. Okay.
okay,
Cool. So
let's
then,
let's move on to 2, unless you've
mhm.
got more questions.
Yeah, no, I'll send it to you.
Yeah, the issue with 2 is there's probably a drawing that's cut off, it looks like.
Yeah, so I'll just reply to that email again.
Okay.
Okay, cool. It's sent.
Okay. Just wait for that to come through. So while it's coming through, I feel like I can find it. We could kind of do this, but it's is Miko on the left, or does it say? Does it
Oh yeah.
actually there it did come in. Never mind. It's the same as it's the same as this last one. Okay.
Mhm.
All right. So again, you got to you sort of draw the triangle as they give it, and then you're going to break it apart. So there's there's
So
these two triangles.
48.6.
Yeah. So this is 48.6. This is 50, and they're 20 feet apart. And we want to know the height of the pyramid. And this will make more sense this time, is to use X on the ground there. Is that okay?
Okay. Yeah.
So again, there's 2 triangles. There's the smaller one where it's X, H, and 50 degrees.
Hmm.
And then there's the larger one, which is H, but now it's 20 plus X on the base because you have to add the 2 lengths together. You can imagine if it's 10 or 30, you just add them together. And then the angle is 48.6. Okay. So the choice here is to use tangent because relative to the angle, you have the opposite and the adjacent.
Hmm.
All right, so you would write the tangent of 50 equals h over x. And then you do the same thing on the right. Tangent of 48.6 equals h over 20 plus x.
All right.
So are you caught up to this step here? You've got the
I am.
triangles. Okay. So just like in the previous problem, you have two equations and two unknowns. So you can solve this. Like this is known, this is a possible solve.
Mhm.
On the left is the simpler equation. So we're choosing to solve that left one for h. Now you might ask, well, why don't we solve it for x? It's because x is in the bottom. That's usually harder to do. It's also the case that if you did solve this for x, you would have a fraction over here on the right and the bottom. So
Oh.
you want to minimize that. Like you want to make the easiest path. They call it the path of least resistance.
Mhm.
And that's a physics circuit term, but we're going to solve this for h. So you're going to multiply both sides by x.
Yep.
Okay. And I'm just going to slightly rewrite it where the variables on the left. H is x tangent 50.
Mhm.
Is that okay?
Yeah.
Okay. Now, when we find the value of x, which is what we're about to do, we're going to put it back into this equation.
Okay.
Okay,
Yeah.
but for right now, we don't know h or x, but we know that this can go into the equation on the right where h is.
Mhm.
So the equation on the right becomes tangent 48.6 equals x tangent 50 over 20 plus x.
Okay.
Is that okay up to this point?
Yeah, I got that.
All right, so I'm just gonna move this over so it's a little easier to solve because this is where the bulk of the work is to solve this. So you want to cross multiply here. So and the reason I put this 20 plus x in parentheses is because it's the whole thing that gets multiplied by tangent 48.6,
Mhm.
and then it's x tangent 50 on the right. I hope you saw this in class or this was
Yeah.
clear. Now on the left, you treat this tangent 48.6. It's really a number. So we can multiply both 20 and the x by whatever this number is, but we're going to keep it as tangent 48.6. So it's 20 tangent 48.6 plus x tangent 48.6 equals x tangent 50.
And you just got that by distributing.
Exactly.
Okay. So.
But it applies to both. Like if you don't put the parentheses around the 20 plus x, you might think it only applies to the x. And it does not.
Mhm.
It applies to both. It's like you and your brother get the same punishment or the same reward, depending on the situation, right?
Got it.
All right. Now you have to get the variables on the same side. You have to get all x's on one side. Okay. So my preference here. Let me know when you get caught up. I don't want to keep going. If you're
Yeah. Sorry.
take your time. I can hear you writing. I don't want to jump ahead too much.
Okay.
So we really want to get all the x's on one side. So you could say, well, hey Matthew, why don't I move the x tangent 50 left? That's fine, but then you got to move this number to the right. Why not just move the variable to the right so that they're both on the right? And that is the preferred path here. So the positive one comes first, x tangent 50 minus x tangent
48.6.
Yes. And because they both have an x in them,
Mhm.
you're going to factor the x out, factor out the x. And you're so close, like the variable's almost right there, ready to be solved for. So you're going to divide both sides by that
So
thing.
you,
Question? Sorry, is there a question?
yes, I guess I'm just a little confused. You can just take out the x.
Yeah, see how it's in both?
Mm-hmm.
I mean, it's a little odd, but yeah, it is. It is in both. See, if you're more comfortable with a calculator, like what a student would do here is they'd find the tangent of 50 times x, tangent of 48.6 times x. So they'd get like something like, actually, let me
Like
do
a
that over.
decimal.
Yeah, they'd get like, oh, it's like 1.3x minus, 0.9x, and then they would combine them.
Mm-hmm.
Maybe that's what you're doing in class.
Yeah, I think
I
that is.
always wait till the end, but it's not wrong to do it this way that you just said.
Yeah, I'll just do it this way.
Okay. So you can literally divide by what's there. If you're going to take more math, if you take physics, you're gonna do more of this kind of calculations where you
Mm-hmm.
end up not doing the calculation until the end.
Okay.
So when you enter this in the calculator on the left, just make sure you put parentheses around the denominator and give that a try and let me know what you come up with.
6 x. Now we divide both sides. Plus. Okay, I got 394.7.
Yeah, so let's just call it 395, just to kind of round up to
Mm-hmm.
units you might use if you were talking about the height of something that tall, and that's reasonable, or that distance. That's a reasonable, but that is not the answer. Like, you feel really good about that, but it's not the
Mm-hmm.
answer because, and you've done a lot of work. Like I don't mean to like trivialize what you've done, but that was X, you want
Yeah.
H, and that's right here. So you take that number and you multiply it by the tangent of 50 to get your final answer.
Oh, wasn't that this was x?
Yes, you just found X.
Oh, because we had found h at the start, so now we're putting x back into that x tan 50.
Say that one more time. You're plugging it in here. Yeah, is what I think I heard.
Yeah, yeah.
Yes, yes.
Okay. So 3, 5, 10, 50. Okay, so H is 470.7.
Yes. And so units do matter. Sorry, because it's kind of sideways here. Feet. That the answer's in feet. So they want you to say that the height is 470 or 71 feet. And that's reasonable. I guess. I don't actually know how tall it is. Still a lot of debate over what the pyramids are actually used for. Because there's actually no.
Yeah.
It's amazing, but that's a different class, not this one. All right, so we got some time left here. What else can I help you with today?
Yeah, I'm gonna look in my book real quick because there's a
Sounds good.
page here that I wanted to just to kind of look at, and then maybe we could come up with a. I think it's a problem that's there.
Sounds good.
Oh man. Okay. So it's actually it's like law of cosines.
Okay.
And then I'm sending it to you right now.
All right, sounds good.
And so just let me know if you got that.
I'm checking. It's in the pipeline here. There it is. All right. Let that load. Okay, so a bunch of problems here. Which ones should we start with?
Oh, sorry. Example 4.
Example 4. So just this example as is, or the guided practice 4A?
Well, I feel like example 4 is already done, so let's do 4A.
Okay, very good. Let me snip this in. All right, so before we get started here on law of cosines, there's two types of law of cosines problems. There's when they give you all three sides, which is the case here, and
Mhm.
you use it to find the angle. The other possibility is they give you a side angle side, and that angle has to be between the two sides, and you use that to find a side. Okay.
Mhm.
Now, I think one of the things that's pretty unclear is that in your book they often give you three formulas for law of cosines, which is really confusing for students. I'm
Mhm.
going to suggest that we label these things a little bit differently so that we have a shot here. Um, let's call the angle that we're trying to find C.
Okay.
I'm sorry. Let me not do it that way. This is C.
Oh.
This is little c.
The
Sorry, I'm doing this all wrong. This is because I would never. Let me redraw this here. Sorry. This is angle C.
Mhm.
This is little c, and then the other ones don't matter. We'll go B and A, little a and little b, like that. Okay.
Okay.
And then I like to actually label them in a format that I'm more used to. Okay, so this
Okay.
transformation or this rewrite is really key for this. Okay, so the basic law of cosines is c squared equals a squared plus b squared. That's the start of it, and that's the
Mhm.
Pythagorean theorem. That's
Mhm.
something you know. Minus 2, and then it's the same two letters on the right hand side of the equation, cosine of the angle that you're trying to find. This should be
And
maybe a bit.
it's always cosine.
It's always cosine. Law of
Oh,
cosines, always cosine.
makes sense.
All right. Now it's just a matter of putting the numbers in. Okay. You could solve for the C, but I would actually in this case put the numbers in. So it's 1.9 squared equals 2.1 squared plus 1.3 squared minus 2 times 2.1, 1.3 cosine of big C. So just putting all those numbers in that were given.
Oh. Cosine. And then we don't know C yet. And that's
What we're trying to find. That's the
like
angle.
X. Yeah,
That's like
okay.
the X, yeah. But this, you actually only have to remember one form of law of cosines, and this is the one that's worth remembering. I know there's three
Uh-huh.
equations, but this is the only one you really need. So from here, we're going to rearrange the equation. We're going to subtract 2.1 squared and subtract 1.3 squared from both sides. So it looks like this: 1.9 squared minus 2.1 squared minus 1.3 squared equals minus 2 times 2.1 times 1.3 cosine C.
Minus 2. Okay.
So now we're going to divide both sides by this thing in front of the cosine. Minus 2 times 2.1 times 1.3. We're going to divide both sides by that. And, I mean, this is your calculator problem. So you're going to let the calculator do this work here.
Can we combine those before we divide, or do we have
Sure.
to?
Yeah, sure. I mean, so what I suggest, this is where I suggest going to the calculator and putting this number in. Like that.
Oh,
So and you're gonna want parentheses in the numerator, parentheses in the denominator. Go ahead and calculate this for us, please. And we'll just make sure we're caught up to this step.
Does does the numerator have to be in parentheses?
Yes.
Okay.
Yes, because you have to do all that first, and then same thing with the bottom.
Okay, I got 0.45.
Yeah, good. And so this is where you're almost done. You have to undo the cosine with the cosine inverse, like this, and that gets you your angle. So let me know what you come up with for that. Or check if it's the same as what I've put on the screen here.
Law of Cosines. 6. Yeah.
Excellent. Okay, I'm gonna stop the recording here.